So very good morning to all of you. So in the previous lectures, in the previous couple of lectures, we have discussed about introduction to surface engineering. So I think hope you people know about that. What is the surface engineering? Why you are going for surface engineering? What is the major need of surface engineering? And also we have discussed about various methods of surface engineering. So I have given a glance about this particular surface engineering, and also we have discussed different kind of methods from the thermal spray to thin film deposition. And in this particular lecture, we are going to discuss or talk the reason why surfaces arises. So the genesis of surface energy and how does surface energy and the properties of surface affects the overall performance of any kind of soil. So that is our major objective of this particular session. Majorly we are talking about what is the surface and what is the surface energy, and also we will discuss what are the major properties, either it is mechanical properties or it may be chemical properties or physical properties. All these properties, how it will affect the surface of the overall performance of any kind of soil. So in the whole course on surface engineering, we must understand what do we mean by surface. So that's majorly this particular course will give a major understanding. Everyone should understand that what is the surface. So then we will move on to the so I think my screen is visible.
Yes, sir.
Okay. So see here our today's lecture majorly we are focusing about what is the surface. So talk about surface and what is the surface energy, and also the properties. The properties nothing but we will talk about physical properties and also mechanical properties, and also we will talk about chemical. That there are different properties are there, but I would like to limit it to some properties. So then first we will go on to what is the surface. So surface essentially is an entity where the continuity of the aggregate breaks down or ends. So here you can see that now if you imagine a set of atoms which either are manifesting in the form of crystals or crystalline aggregate, where we have a three-dimensional periodicity, or if you can have any kind of situation where do not have a two-dimensional periodicity. So here majorly we will talk about where exactly there is a three-dimensional periodicity. If there is a continuity of atomic aggregate breaks, so then a surface arises. So that please remember the point is very clear here. So if the continuity of atomic aggregates are breaks down, then surface arises. So be it either it is a crystalline or amorphous, in either cases we will have a situation where a certain continuity gets breakdown or ends at a particular site. So where such continuity ends, we create a surface. So that is the majorly you have to remember where the atomic aggregate breaks down or ends, then only surfaces arises. So here the thing is that surfaces can exist even inside the solid, which we do not get to see by naked eye, because we have the solid in the probability is an opaque solid. So because of that opaque solid, we can't easily visualize that if there are any kind of surfaces arises inside the solid. But that is also the probability. There is a chance to formation of surfaces inside the body. That is majorly we call it is dislocations and all the things due to the we call it is a misorientations of the brains, okay, or dislocations. Also called it is because of the defects of the defects in the solids. Due to that things, there is surfaces arises inside the surface. So that is will be also there. So don't expect the surface is only the external. So the surfaces can create inside the solid. So, but if it is like a transparent solid, you may actually discover that there are interfaces within that. So, you can easily, if whatever the solid body you are consider, if the solid body having like transparent, then you can easily visualize what exactly happens inside. So always the surfaces are, we have external surfaces as well as the internal surfaces. Both is possible. So the internal surfaces may causes because of the defects or we call it is the misorientations or dislocations of the atoms and all the things. Internal surfaces can create. So, so in general, let us say a surface is essentially a situation where the atomic or ionic or molecular aggregate and it's a discontinuity, and a kind of situation where the continuity breaks down can happen either at external surfaces it is external surfaces which is like solid vapor interface or within the boundary, so within the bulk of the solid, so and which we call it is internal boundaries or it is external surfaces. So majorly these kind of boundaries are we call it is vapor solid. So this is the one kind of internal boundary, otherwise called it is external. So this is the vapor solid or maybe liquid solid or solid interfaces. So these are different kind of things, and there are another things also there, but majorly we are focusing about the internal boundaries as well as external ones. Okay. So here, so boundaries are surface interface. They essentially lead to the fact that there is a discontinuity of periodicity. So discontinuity of periodicity, nothing but because atoms are because if you consider it three-dimensional, maybe it is amorphous or it may be crystalline structure. If there is a change in that, if atoms orientation is changed, that obviously, so that aggregate breaks means whatever the continuity that will be breaks. Then obviously there is a new surface will arises. So that's why it is always lead to the fact that there is a discontinuity of periodicity that having certain defect in the densities, and we certainly have break the bonds. So because we do not maintain the same surroundings as we can have inside or interior of the crystal. So because when there is changes the energies outside and inside, then obviously there is a chance to break these boundaries like bonds. When there is bonds breaks, then there is a new surfaces arises. So then because of this discontinuity of periodicity and the defect in the densities as well as the broken with bonds, it will lead to or it will result in the releases some energy. So So that energy which is different from the inside the bulb. So that will, so whenever the brakes burns, then it will releases some energy. So this is all about the surface and what is surface and interfaces, or what is the external surface and what is the internal boundaries, and also what is this boundary, surface, interfaces. And we will talk about very important, that is the solid interface. So which is very important, and also we will define that all the properties of solids, so that we see they can be have two types. Either it is so-called homophase or grain boundary. So that is called as solid-solid interface. So I think in your secondary level we will talk about microstructure analysis in your metallurgy laboratory. There is a grain boundary. So grain boundary nothing but what? There is a small boundary between two phases. The two phases are solid. So that's why the solid-solid interface is called as a homophase or grain boundary. Because there is another thing, that is the heterophase, or we call it is phase boundary. So phase boundary is a different and grain boundary is a different. The boundary between two grains, that is the one thing, and another one is the boundary between the two phases. So what is this? What is the grain boundary? How we are define a grain boundary, and how we are define a phase boundary? So see that if whatever the entities across a particular boundary are having same crystal structure and the same composition, only a different in the orientation. So we are simply called it as homophase or a grain boundary. So that you clearly understand what is the grain boundary. So the entities across a particular boundary are having the same crystal structure and the same composition, but only different in the orientation. So then we will simply call it as homophase or grain boundary. Then how we are defining this heterophase or phase boundary? It is simply opposite that. So if there is entities across the boundary having a different crystal structure, different composition, there is a different in orientation, then we will simply call it as phase boundary. So this is the solid-solid interface. This is a very important for the in thermal spray coating. So whenever you are going for a thermal spray coatings, so initially it is liquid, after that it will convert into solid. Then we'll talk about these solid-solid interfaces. So then we will go for surface energy, how we are defining this surface energy and all the things. So see here how we are defining that surface energy quantifies that there is disruption of intermolecular bonds that occur when surface is created. So that's, I already told you that how the surfaces arises, but due to this surfaces arises or surfaces created, there is a disruption of intermolecular bonds. So that obviously it will create energy. So that energy will be called as surface energy. So for a liquid, due to this surface tension and surface energy densities are like identical. So you know that all these things will happen. And now we will talk about one important concept in this particular surface engineering, that is wetting, and also called it is like a contact angles. So with the help of contact angle, we can simply say that whether it is good wettability or not. So see, I think everyone familiar with this particular concept. If you have a water droplet, so if water droplet fall on this lotus leaf, so what is the situation? Did you get any kind of good like interactions between the leaf and water droplet? It is not possible. You are not getting a good bond between the water droplet and lotus leaf. So here the same concept here also we are using in solar panels also. So that's I will explain that how this wettability concept will helpful in solar panel manufacturing. So see here we have a solid and it is a liquid. So this is your solid and there is a liquid droplet fall on this. So obviously there is three different kind of energy sizes here. One is that this is one surface energy, we will represent as a gamma. So this is the vapor phase and this one is the liquid phase. So there is interactions between liquid and vapor. So this is the surface energy. And we have another one. So this is another one. So this is the interaction between surface energy, solid and vapor, and this is the surface energy, gamma, liquid and solid. These are the three different kinds of forces interact at this particular rate. So this is the good analogy to explain about this wetting concept and all the things. And this is the theta. This is simply called it as theta. So this theta is the parameter. Will explain the whether it will easily spread over the surface or not. So that will explain by this contact angle or theta. So see, once we are equating that forces and all that is this gamma SV and surface energy solid vapor will balance these two forces. So our gamma SV is equal to gamma LS plus gamma LV cos theta. Gamma LV cos theta. So here you can easily measure this cos theta. This cos theta is equal to gamma SV minus gamma LS divided by gamma LV. So then you can easily identify that theta is equal to cos inverse of gamma SV minus gamma LS divided by gamma LV. So like that we can simply measure this theta value. But once you get a theta, what you will understand by this theta? So here you can see that this is the theta and this is also theta. If theta is less, then you can see that it can easily spread over the surface. If theta is more, and you are not getting spread over the surface. So here deciding factor, if theta is less than 90, then it is good wetting. So means our liquid is easily spread over the surface. If theta is greater than 90, so here you can see the example here. If theta is greater than 90, then no wet. There is no wetting. Means our liquid is not spread over your surface. So this is like hydrophilic and this is the hydrophobic. In some situations we require hydrophilic and some situations we require hydrophobic. And you clearly understand here there is a contaminated solid. Because if there is any contaminations on the solid and you are getting hydrophobic in nature. Okay. So then we will move on to, and you see that surface energies. So surface may be defined as the interface between the two identical or dissimilar phases or grains that we have discussed in the previous slides. And here you can see that how we are measuring the surface energy and all the things. Here there is a one diagram. It will clearly give understanding what is this wettability concept and all the things. So see here, if theta is 0, if theta is equal to 0, you see that means it is a complete wettable. So once the liquid droplet fall on the surface, it will simply spread over. You can see that. It will simply spread over. And here you can see that means always if theta is less than 90, then it is good. If theta is greater than 90, then obviously you understand that if there is theta is in between 180 degrees, then obviously you understand there is a partial wetting. If it is like around 180, means we are getting no wetting here. You can see that no wetting. For understanding, there is another diagrams also. This is a complete wetting, this is a partial wetting, here not wetting. You understand here. There is only a point contact between the surface and our droplet. And this is the very, very important in case of our solar panels. So whatever the droplet fall on the, because due to the rains or anything, so if it is simply stick onto that particular surface, then obviously there is a change in the energies and all the things. So that is the reason why once a rain droplet or any water droplet or any dust particle fall on the solar panel, that should not be stick on the panel. So that is a very important. So whatever the droplet fall on the solar panels, if the contact angle is less than 90, then obviously what happens, it will simply spread over the surface. Then obviously what happens, so whatever the sunrise fall on that intensity will be comes down. So that is the reason why if the interaction between these surface and the droplet, like if it is a hydrophobic, then obviously you are not getting any kind of wetting. So if there is no wet, it will simply comes down. So this is one of the important concept that they are using in solar panels. But here what the thing is that they are trying to modify the surface. If you modify the surface, then you can reduce the contact angle. So it means you can increase in the theta value. If theta value is 180 degrees, then there is no good interaction between the droplet and the surfaces. Hope you understand that what is this surface and what is the surface energies. Okay. So now we are move on to another concept, that is surface dependent engineering properties, and majorly three different kind of properties. So there is a physical properties will depend upon the surface, and mechanical and chemical. So because of these properties, so entire material performance will vary. So all these properties, whatever I have shown on the screen, all these are only surface dependent properties. These are all not bulk material properties. These are only surface properties. So in case of physical properties, like we have roughness, and color or reflection, emission, wetting or absorption, adhesion or coincidence. All these are all only surface dependent properties, all are physical properties. And also we are coming into the mechanical properties, hardness, friction, wear, fatigue, fracture. So you can see that all the five mechanical properties are only surface dependent properties. These are all not bulk material properties. I think hope you know in your secondary level we have done this hardness test. So what exactly we are do that? We are simply form one indentation on the surface. So and also even the friction also it is the surface, and wear also each and every property depends upon the surface. But if you modify the surface, okay, we are trying to modify only surface, but it will reflect the entire performance of entire solid body or entire bulk materials. So that is the reason why we are not modified entire bulk material. We are trying to identify that which properties are affecting the surface, and we are trying to modify those properties. So, and also chemical properties. So like there is a reactivity, oxidation, corrosion, and catalysis, as well as high temperature oxidations. All these things will affects only uh, surfaces. You know, in the corrosion there is sometimes internal also it will happens, because there is some kind of some types of corrosions are there, intergranular corrosion and all the things, but that is also happens between the solid surface. So that is internal happen, that one is also happens on solid surface. So that's why all we consider it uh, surface dependent engineering properties. So first we will talk about some mechanical properties, what is the hardness and friction, how it will be effect on surface and all that. So surface dependent mechanical properties we will discuss. So I think everyone know about what is the hardness. Hardness is resistant to indentation, scratch, and all the things. Here, majorly, it expresses how resistant solid matter is to various kinds of permanent shape changes when there is a compressive forces is applied. So we are applying different compressive forces. There is a different kind of indentations. Here, our intention is that how resistant the solid matter. So, but here you clearly understand that we are applying only on the surface level, and the entire hardness is depends on only surface. So, we are not applying any kind of force inside the material, only we are applying the force on a surface level. So, that's if you modify the surface, and our hardness will be varied. So that's why hardness is depends upon surface. So you can see that if you take one material, a low carbon steels, consider low carbon steel. So measure its hardness, know the value, and then you can simply go for any quenching operation, go for heat treatment. In the quenching operation, only outside surface only modify. Inside it is simply cold. It means it is soft. So after quenching operation, once again you measure its hardness. Then obviously hardness will be varied. So hardness definitely it will increase. So once the hardness increases, then obviously the performance of the component will increase. Then obviously life of the component will increase. That is the meaning of the performance. Okay. So then another one, that is friction. So you know that friction is also one kind of surface dependent mechanical property. So friction is the force resisting the relative motion between the solid surfaces or fluid layers or any material elements sliding against each other. Like you can see that there is rack and pinion mechanism in this particular diagram. Here, there is a relative motion between two things. So your pinion will continuously. So obviously, when there is a contact between the uh, uh, two metallic or maybe fluid layers, then there is friction will develop. So, so sometimes friction will more and sometimes friction will be less. So all these will definitely affect on your performance of that particular structure or component. If friction will more, then obviously what happens, heat generation will be more. If more amount of heat generation, then obviously what will happen, so material loss will be more. So always, that is the reason why in that particular situation we are always trying to reduce the friction. So how to reduce the friction? Either you can add some lubrications and all that. So this is also a surface dependent property. So here we are not talking about any bulk materials, only we are talking about its surface. So later we are talking about so lubrications. So you know that everyone know about this lubrication. Then why are going for this lubrication is a system. So apply to majorly reduce the friction between any two uh, contacting parts. So because of this particular relative moving of each other, then obviously what happens, the same concept will become here. More amount of heat will be generated and material loss will be there. To eliminate to reduce that kind of phenomenon, we have to add lubricants. That lubricants may be in terms of solids or maybe liquids. So you can see that in case of liquid we are going for grease, otherwise in the solid we are going for molybdenum and all the things. So this is the major about that lubrication. So lubrication is also one kind of surface dependent property. So and we are talking about another one. So that is the wear or abrasion. This is a very important nowadays. Lot of research is going on this particular area. So here how we are defining these. Where can be defined? It is a process where the interaction between the two surfaces or two bounding faces of solids. So within the working environment results there is a dimensional loss of one solid. So sometimes it is possible on two solids, or if it is so any one component having more mechanical properties or like more hardness, then that will be effect on another component. So that's why here majorly we have mentioned about like there is a dimensional loss of one solid without any actual decoupling and loss of materials. So here the where is like erosion. Majorly we talk about erosion, nothing but there is a loss in materials loss. Once there is a material loss, then obviously what will happen? There is change in the dimensions. So maybe lengthwise or widthwise or value wise. Then obviously there is a dimensional changes happens. Once there is a change in the dimensional, then what happens? It's a performance. Obviously, performance will be comes down. So here you can see the diagram for better understanding that there is like a sprocket here. One this is so here you can see here. So this is the new one. There is no dimensional loss in that particular sprocket, but here in the right side you can see that there is a change, dimensional changes at the ends. Why it is happens? Because there is continuously there is a contact between the chains and all the things. Then obviously some amount of material. So all these are only depends upon surface. So if you protect this surface, if you protect this surface, then obviously that will increase in the life of the component. So here that's why all these mechanicals like what we have discussed, the friction, the wear, lubricant, all these things are directly affect on this surface. So that's why we are always trying to protecting or modifying this surface. Okay. So and also we have another one like fatigue fractures. Both are like surface properties here. You know the fatigue when the fatigue exactly occurs when the material is subjected to there is a repeated loads or unloadings. If you are going for repeated loading and unloading, then obviously this fatigue will occurs. So here fatigue is usually under the tensile stresses, but fatigue cracks may occur due to the compressive loads too. So both tensile as well as the compressive will happen. So and also we have another one, that is fracture is also one kind of surface dependent means here fracture is the separation of object. I think in the previous class somebody asked the question is that what is the fracture. So here always the fracture occurs when there is a certain displacement or discontinuity or crack develops. Once the crack develops or any discontinuity develop, later if it is propagates, then entire structure fail. So here you can easily control that. You can easily control that fractures by modifying the outer surfaces. So if you modify the outer surfaces, then you can not easily generate the cracks or discontinuities. So that is the reason why the fracture is also surface dependent. So and also we talk about some surface dependent physical properties. Here one is the roughness. This is a very important. Roughness plays a major role in the art. So here you can calculate that average hour value, what is the length of these peaks and valleys. So you can easily measure the roughness, but roughness plays a major role in that entire surface engineering, because if you have low surfaces, low surface roughness, there is less in the mechanical interlockings. If it is high roughness, there is a problem with that contact angles. That is a very important. That is the reason why you have to optimize these roughness values. Okay. So how we are measuring the roughness? We are going for any profilometers, and there is optical white light based profilometers, laser light, or going for AFM technique, that is called as atomic force microscopy. So these are all different kind of measurement of surface roughnesses, but we have to optimize this roughness value, because low roughness as well as the high roughness is not suitable for that. So we have to optimize as per our application, because if it is a high roughness, there is problem with the contact angles. Okay, and we'll talk about the wetting. So wetting is a one kind of physical properties. I think everyone know about these wetting. I already explained this particular wetting. So what is nothing but wetting is that ability of a liquid to maintain the contact with the solid surface. And here you can see that your liquid is simply good contact, mean to maintain a good contact with the surface. So this is the total wetting. So but here you can see that it is a partial wetting. Here again it is a partial wetting, and you are getting it is a hydrophobic, and this is the hydrophilic, and this is there is no wetting, only a point contact between the surface and the liquid. So so you have to avoid these kind of situations whenever you require a good interface between two solids. So here you can see that there is some examples also there for non-stick fry pans. We are coated with Teflons. So whenever you are coating with Teflon, then there is no contact between the our pan. So as per our applications, we have to go for. Sometimes we are going for raincoats. Our raincoats. Why our raincoats also like hydrophobic materials. So obviously, when you were our raincoat made with this hydrophobic material, once the rain droplet fall on that raincoat, it won't stick on that. It will simply falls down, because there is no contact angle is around 180 degrees. So if the contact angle is 180 degrees and you are not getting good better. So like that, there is a wax paper cups and all the things, because all these are all hydrophobics. Some kind of ceramic cups, and we are going for coating on that. So because we don't want sticks. Right now I have seen in that Amazon and somewhere we are getting different textiles also. So in that particular shirt, if the cup of coffee or something, or tea or fall on that particular shirt, it won't stick to that. So that is made up of hydrophobic materials. So once you understand the principles, and you can simply apply those kind of principles into real-time existence. That is the thing. So here we know about what is the wetting and what is the non-wetting, and you know what is the hydrophilic and what is the hydrophobic. So according to that, if you modified your surface or if you modified your liquid droplet, then you can use in our real-time application. That's why we are modeling using non-stick fry pans as well as raincoats or wax paper cups and all that. So all these are all good examples for this wetting concept. Okay. So see, there is the adhesion component. So say we want to know about that. What is the adhesion and what is the cogency? So in the adhesion, there is a tendency of the there is a dissimilar particles or surfaces to adhere one to each other. So you can see that there is a one component, there is another component. Substrate is a different material, and your deposition material is a different. So when there is contact to each other, that is called as a adhesion. So this the interface is a very important interface. The two materials are bonded. So you have to check the compatibility, whether these two materials are good compatibility or not. And also cogency. So cogency, everyone know about this is the tendency of similar or identical molecules or surfaces to adhere to one and each other. Maybe water is one of the best example. It is a strongly coalesce each other molecules with the 4 hydrogen bonds. That's why we're getting H2O and other things. So this is the one of the good example. So another important thing, that is the surface dependent chemical properties. So there is a lot of examples also there for surface dependent. I have explained that chemical properties, but today I would like to go for only one, that is corrosion. So everyone know about this corrosion. So it is like a natural process by which solids may be deteriorate because of the galvanic action, or maybe it is oxidation that creates mixed oxides from the spar from the base. So you know that galvanic corrosion, otherwise called it is two metallic corrosions, when there is a two different metals have physical or electrical contact each other, and if you are immersed in any kind of electrolyte, either it is a normal water or it may be the sea water or any kind of NaCl solution or anything, so then obviously because of that variation in the galvanic series is, then one material may get corrosion. So and another one, there is a cathodic reaction will be takes place. This is a very important in case of marine applications and all the things, because if you would like to join two components in any kind of marine applications, so there is a two metal contact, and that will be immersed in electrolyte solutions like in a seawater. So if anything, nothing but whenever you are selecting the two materials of different materials, and also if you don't have how to select the materials, then there is a chance to fail the entire structure due to this particular effect of galvanic corrosion. So that will explain about in the corrosion chapter. So how to select the materials and all the things, because this is a very important two metal corrosion or galvanic corrosion. So I think this is today's lecture. I hope you understand this. What is the surface and what is the surface energies, and also what are the properties or affecting the surface. So because to going to the entire surface engineering concept, should know about this minimum principles. Why? Because whenever you want to analyze the microstructure, or if you analyze any kind of components, then definitely you need these kind of principles. Then only you can easily analyze that kind of microstructures. So I would like to go for a small poll question. So meanwhile, if you have any doubts, then you can simply post in the chat box. Otherwise, you can directly ask.
I'm here. Yes. కాలేజీలో రావడం కాదు అమ్మా అమ్మా రే
Please, all of you check. All of you check in your chat box. Okay, I got one question here, like how dislocation causes surface energy. You know what is the dislocation? There is a discontinuity of the atoms. So when there is a discontinuity of the atoms, then obviously it will create some energy. So once the discontinuity breaks down, it requires some energy and also it will generate some energy. That energy we will call as surface energy. So means you are getting a separate interface inside the body.
Sir, but it's not caused to the surface, sir. It's meant to be in internal of the material, sir.
Santosh, good morning. Santosh. Santosh, am I audible? Harika, am I audible?
Yes, sir.
Okay. So your class is completed now.
Yes, sir. Yes, sir.
So I request all of you leave the meeting if it is completed.
Okay, sir.
Okay, sir. Okay, sir.
Okay, sir.
Okay. Santosh.